Hi everyone. Today the topic on which we are going to talk about is on concentration cell with transference. So, what are concentration cells? It is a cell in which electrical energy is produced by the transference of a substances from a system of high concentration to one at low concentration. This is known as concentration cell. Or you can say a cell in which EMF depends upon the difference of concentration. So, types of concentration cells. They are of two types. First, electrode concentration cells, or you can call it as a amalgam cells. Under this, we have without transference, and the second one is electrolyte concentration cell. This is further divided into two, without and with transference. Electrolyte concentration cell with transference. This is a type of cell where the liquid junction potential between the junction of two solutions is taken place into account. Both the electrodes are hydrogen electrodes. The electrodes are immersed in the solution of difference H plus solution concentration, which are in direct contact with each other, and no salt bridge is used. The cell representation is this. Now, in the above cell, two solutions of HCl are in contact with each other, and thus there is a direct transfer of hydrochloric acid from the concentrated solution A2 to the less concentrated solution A1. In general, whenever two solutions of the electrolyte of two concentrations are placed together and the electrode reversible with respect to one of the ions of the electrolyte is kept in each solution, then a concentration cell with transport will be obtained. In the above cell, the dotted line represents the liquid junction potential. At the liquid junction, electrodes flow in the external circuit from left to right. H plus are produced in the left electrodes, whereas the Cl negative are left behind in the right electrodes. Hence, the inner circuit is completed by transference of Cl negative ions from the right to the left and H plus from left to the right across the junction. At the electrodes, oxidation takes place on the left hand side, whereas reduction on the right hand side. Now, the sum of these two electrode reaction is this. This is the equation number 1. Now, suppose we have Tc and Ta are the numbers of H plus and Cl negative respectively. Here, the Tc represents the transport number of cation, whereas Ta is nothing but transport number of anion. In simple words, we can say that it can be said that Tc equivalent of current is carried by H plus ions, whereas Ta equivalent of current by Cl negative ions. Now, for the passage of 1 Faraday of electricity through the cell, that Tc Faraday is carried by ion of hydrogen from left to right, that is from the solution of activity 1 to activity 2. Then we have TCH plus of A1 is equal to TCH plus of A2. Now we know that Tc plus Ta is equal to 1. So we can write it as Tc is equal to 1 minus Ta. Now substituting, we get 1 minus TAH plus A1 is equal to 1 minus TAH plus A2. This is the equation number 2. Also, Ta Faraday of electricity will be carried by Ta of chloride ion from right to left, from the activity 1 to activity 2. Then we have TaCl negative A2 is equal to TaCl negative A1. This is the equation number 3. In order to obtain the net transfer of material from the two solutions will be obtained by adding equation 1 from the previous slides and equation number 2 and equation number 3. So we are going to get H plus A1, A2 plus 1 minus TaH plus A1 plus TaCl negative A2 is equal to H plus A1 plus 1 minus TaH plus A2 plus TaCl negative A1. As we know that 1 minus T is nothing but 1. So we are going to write H plus A2 plus H plus A1 minus TH plus A1 plus TaCl negative A2 is equal to H plus A1 plus H plus A2 minus TaH plus A2 plus TaCl negative A1. Now cancelling both the H plus A2 on either side and H plus A1, we get minus TH plus A1 plus TaCl negative A2 minus TaH plus A2 plus TaCl negative A1. After taking both the A2s on one side and A1 on other side, we are going to get TaH plus A2 plus TaCl negative A2, TaH plus A1 plus TaCl negative A1, which leads to the removing of minus. Now, taking both the TaS on one side, we get TaH plus A2 plus Cl negative A2 is equal to same on the other side, TaH plus A1 plus Cl negative A1. Then we get Ta of HCl A2 is equal to Ta of HCl A1. This is our equation number 4. It is evident that Ta is equivalent of HCl is transferred from the solution of activity A2 to A1 by the passage of 1 Faraday. Now, applying Nernst equation, the EMF of the complete cell will be given by this. After solving further, taking Ta on one side, we get this. For EMF to be positive, A2 must be greater than A1. Replacing the activities by molarities and activity coefficients and rearranging the same, we get this. Whereas M2 and Y2 is nothing but A. And further we get E is equal to 2Ta RT upon F log E A2 upon A1. Now coming to the problems. The concentration of cell has a EMF of 0.1074 volts. Formulate the corresponding cell with transference for which the EMF is found to be minus 0.0537 volts. Find out the transport number of chloride ion. A solution for this is the concentration. The construction of the cell with transference will be being reversible with respect to chloride ion. This cell has an EMF which is given by ET is equal to 2T plus RT upon F log C A1 upon A2. The EMF of the given cell is E is equal to 2RT upon F log C A1 upon A2. Therefore, T plus is equal to ET upon E. ET is minus 0.0537 whereas E is minus 0.1074. Then we get T plus is equal to 0.498. Therefore, transport number of chloride ion is 1 minus 0.498 is equal to 0.502. The second problem. Which of the following is an example of electrolyte concentration cell with transference? For this, the answer is going to be the D option. That means there is a junction, liquid junction in the middle, representing the liquid junction, the dotted lines. So this is an concentration cell with transference. Question number 3. Find out the expression for EMF of concentration cell with transference. Electrolyte concentration cells with transference of this is expression for EMF of an electrolyte concentration cell with transference reversible to cation is given by E cell is equal to T minus 2.303 RT upon NF log A2 upon A1, where T is transport number of an ion and F is a Faraday. When A1 is greater than A2, it means that first option, the right hand electron will become negative and the left hand electrode will get positive charge. The second one, the left hand electrode will become negative and the right hand electrode will get positive charge. Or the third one, both the left and right hand electrode will be positive. D, both the left and right hand electrode will be negative. As we know, A1 is greater than A2, so it is going to be option B. The left hand electrode will become negative and the right hand electrode will be positive charge. Moving on to the fifth question, the activity A is related to activity coefficient Y, lambda, can say by the equation D, A is equal to M into lambda. The concentration cell which has liquid junction in its representation is electrolyte concentration with transference, or electrolyte concentration cell without transference, or electrolyte concentration cell, or gas concentration cell. So our correct answer is electrolyte concentration cell with transference. As we have seen before that electrolyte concentration cell with transference will have liquid junction in its cell. Thank you everyone.